Hi guys, so let's have a look at this question number 14 from your second paper that you guys took at the end of last year. Let's read the question first. So it says the diagram shows a piece of wood cut into the shape of a triangular prism. Here, the piece of wood is 5 centimeters by 12 centimeters by 2.3 meters. So already I found something in this question that I need to act on. You see how all these dimensions, the 5 and the 12, are centimeters. The last one is in meters. So I want to bring them all to the same unit. So I'm going to turn this meter into centimeters. You can work in centimeters, it doesn't really matter. You can work in meters, whatever you choose, just be consistent throughout the question. So I've got 2.3 meters is equal to get from meters to centimeters, we times by 100. So that's going to be equal to 230 centimeters. So now everything is in the same unit. The mass of the piece of wood is 6.5 kilograms. So already I've got all the information I need to work out the volume. It's talking about mass, so I know this is going to be a density question. But let's carry on. So it says the piece of wood will float in seawater if the density of the wood is less than the density of the seawater. So there you go. We want to work out both densities and see which one is higher, which one is lower. Then it says in a large pool, 1 liter of seawater has a mass of 980 grams. Will the piece of wood float in this pool? We must show how we get our answer. So we must show complete working out basically. So we already made a start here transforming everything into the same unit. So I'm now going to carry on and I'm going to work out the volume of this triangular prism, because I remember that the formula for density is equal to mass over volume. So I need the volume for this. So the volume of the wood, in these worded questions that I can kind of label what I'm working out. So the volume of the wood is equal to 5 times 12. So the area of my cross section, which is a triangle, so I need to divide that by 2 and then multiply that by the length of the whole shape, so of the whole prism. So multiply that by 230 centimeters. Okay, so if I just grab a calculator, hopefully you guys had time to grab one as well, you're trying this. And I am getting, you can type all that in your calculator and you are going to get, there you go, 6,900 centimeters cubed. Okay, because all these units are centimeters. So there you go, we get our final answer in centimeters cubed. Great. So we now have the mass of the piece of wood. We've got the volume of the piece of wood, so we can work out the density of it. So the density of the wood is equal to, if I now cover the density, I know that I'm going to have to do mass divided by volume to work it out. So the mass of the piece of wood, it gives me in the question, is 6.5 kilograms. With this one, because I'm kind of scanning ahead, we've already read the question, we'd probably want to turn it into grams as well. So we have the same kind of like unit, or it depends what you want to do, whether you want to work in grams or in kilograms or in centimeters or meters. You kind of have to make a decision. So I'm going to go for grams in this one. So I'm going to times that by 1,000, because there's 1,000 grams in a kilogram, and I'm going to get 6,500 grams. Great. So now everything in like both masses are in the same unit, I can proceed. So I'm going to do my density of wood, 6,500, divided by the volume of wood, 6,900. So if I type that in my calculator, I am going to get 0.942, and they are grams over centimeters cubed. Okay, because we divided grams by centimeters cubed, obviously our answer is going to be in grams divided by centimeters cubed. Now my answer is rounded to 3 significant figures. Great. So we did everything we could with the wood. Let's do something about the water, and I'm going to choose blue, probably predictively. Okay, so let's work on the water. Now it says in a large pool 1 liter of seawater has a mass of 980 grams, which is awesome, but it kind of feels like they're not giving you enough information to carry on. But they actually do, because in this bit here, 1 liter of seawater, or 1 liter, you hopefully are going to be able to memorize for your exam that 1 liter is equal to 1000 centimeters cubed. Okay, so that's a really cool conversion, nice to remember for when you have something like this to do with density, and you can apply it obviously backwards as well. So if they give you stuff in centimeters cubed, if it's necessary, you can turn it into liters. Great. So what this means is that I actually have volume here, because remember, units cubed are volume, so that I know my volume of water is equal to thankfully it's just 1 liter, so it's going to be 1000 centimeters cubed. Okay, I have my mass of water, which is equal to 980 grams. So now I can do my stuff. I can work out the density of the water. So the density of the water is equal to, again, mass over volume. So I'm going to go with the mass, which is 980 grams, divided by the volume, which is 1000 centimeters cubed. So if I type that in my calculator, I'm going to get 0.98 grams over centimeters cubed. Great. So now I've got the density of the water, which is 0.98 grams per centimeter cubed. I've got the density of wood, which is 0.942 grams per centimeter cubed. I can go back to this, which says the piece of wood will float in the seawater if the density of the wood is less than the density of the seawater. So you can say that the density of the wood is less than the density of the seawater. And personally, I would probably say it as something a little like this. So I'd use my inequality signs. So 0.942 is smaller than, sorry, there's some sort of lag here, so 0.98. This is the wood, this is the water. So yes, it will float. I'm just waiting for all the writing to come up. Anyway. Okay, so yes, it will float, and that's because of this. The density of the water is higher than the density of the wood. There you go.